All right, so today we're going to move on to the next section of Chapter 5, which is going to add in a couple more shortcuts for proving triangles congruent. So if you remember in the last section, we talked about side, 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 side angle side, and hypotenuse leg, and those are three shortcuts we could use to show that two triangles were congruent to one another. We're going to throw two more into the mix with ASA and AAS, and we'll talk about those here in a second. Before we get into that, though, we're going to do a little bit of review on included versus non-included, so what those terms actually mean. So in these examples here, we've got this triangle off to the right, so triangle TEG. It says name the included side to angle E and angle T. So they're talking about angle E here in the top, and then angle T down here in the bottom left. We want to know what side is included, meaning in between or touching both angles. So the only side in this triangle that actually touches both angles would be this side over here. And so if we name that, that would be side ET, so line segment ET, or you can have it in the reverse order, say line segment TE. Either way, as long as you have the line segment symbol with the two letters. So side TE would be in between those two particular angles. The next example says name the included angle between sides TG and TE. So if we get rid of some of this here, so for this example, it says the included angle to TG and TE. So TG is this bottom side, TE is this top left side. The angle that's included or in between would be this angle T that touches both sides. So for the included angle, we'd be talking about angle T. So remember, with included, we're talking about in between. So a side that's in between the two angles, or the angle that's in between the two sides. So when you see that word included, you're thinking in between. Now for non-included, so same triangle, but now for the non-included sides or angles. So in this first example, it says name the non-included side to angle E and angle T. So again, angle E is at the top here, angle T is at the bottom left. So we want the sides that are not in between. So side TE on the last slide was the one that's in between. We want to pick a side that's not. So we could actually pick side EG over here on the right. So line EG would be non-included. It's not in between or doesn't touch both angles. Or we could actually use the other side, GT, because that also does not touch both angles. So when we're talking included, it's got to touch both pieces. So EG and GT both do not touch both angles that are marked, and so those would be non-included sides. If we look at the next example, it talks about the non-included side to angle G and angle E. So angle G is down here in the bottom right, angle E is in the top here. So the side that's in between would be E to G. We're not looking for that though. We want anything that's not touching both angles. So again, I could choose this bottom side GT, or I could choose the left side ET, because those two sides, neither one is included between E and G. Neither one touches both angles. So one of the things that's going to be really important in this section is being able to decide is the side in between or not in between the two angles marked, because that's going to be the whole idea behind ASA and AAS. So if we get into ASA, just like with the other shortcuts, the ASA stands for angle, side, angle. So the A for angle, the S for side. Now the order is important. It means we have an angle, followed by a side, followed by another angle. So it has got to be two angles, and the side is in between the two angles. So that's the included side. So the postulate itself says if two corresponding angles and the included side, so that's a really important thing here. The side in between the two angles are congruent, then the triangles are congruent. So if we look in the picture down below, we have angle E up top marked congruent to angle L. We have angle T in the bottom left marked with angle M in the bottom right over here. So we have two angles, and then the sides that are marked ET and LM are included. They are in between. So if I look at this side LM, it touches both angles. Side ET touches both angles. So that's an included side, which means we have ASA. So angle, side, angle. So when we go to talk about these triangles, we say that they're congruent. So we make the statement like triangle TEG is congruent to triangle. Now, I'd be careful with my order. I went from T to E to G, so to match up corresponding parts in the other triangle, I would start at M, go to L, and then go to P. So T to M, E to L, G to P. And then I would say by, in this case, ASA. So I had two angles, side in between for ASA. Now the other shortcut is very similar. It has two angles and a side as well, but again, order is extremely important. In this case, we're talking about angle, then another angle, and then a side that's not in between. So this time we're talking non-included. So if two corresponding angles and the non-included sides of two triangles are congruent, the triangles are congruent. So now if we take a look at the picture down below here, they have two angles. So they have this top angle in the green with this bottom left angle in the blue. And then we have the left angle in the green matched up with this bottom right angle in the blue. And then when we look at the side that they marked, we have this side down here with this side over here. Now if I look there, that side, if I highlight the side in green, this side doesn't touch both angles. It just touches this one on the left. Same thing over here, it doesn't touch both angles. It just touches the one on the bottom right there. So what's happening here is we have an angle, then another angle, and then the side is not in between. So when you're identifying these shortcuts, it's really important that once we have two angles and a side, we're congruent, but we have to look at where that side is. If it's in between the two angles, then we write ASA. We put the S in between the A's. If the side is not in between the angle, then we put the side outside of the A. So it's AA, then S. So when you're doing these theorems and where you're using these shortcuts, be really careful with these two because they're very similar and they look a lot alike. So if we look at some examples here, in the two triangles that we see here, on the first triangle, so if we talk about this triangle 1 and triangle 2 here, they're saying name the postulate that makes each triangle congruent if possible. So if we don't have enough information, we simply write not enough information. Now if I look at this first triangle here, I've got one angle marked congruent to another angle. I've got one side marked congruent to the other side. Now on its own, that would not be enough information to show that the triangles are congruent. But what we have to account for here is that in the middle of the picture, we have vertical angles. And while they won't mark vertical angles for us, we know that we have to do that. We know we get to do that because vertical angles are always congruent to each other. So with those vertical angles, I can mark them in. Now if we look, I have two angles and a side. So all I have to do is determine if I highlight the side. So here's the side that was marked over here. If it doesn't touch both angles, so in this case it only touches the red angle, not the blue, that means the side is outside the angles. It's not included. So this would be angle, angle, side on the outside. Okay, same thing on the other side. If I look at this side over here, it only touches the red angle, not the blue. So this is AAS for this particular situation. Now if we look at the second example, so call this triangle 3 and triangle 4. So if we look at these two triangles, we notice that they have this angle up here marked with this angle down here. They have this angle up top here marked with this angle down here. And then that's all they give us. Now in this case, two angles on its own is not enough to say the triangles are congruent. But just like in the last example, we do see a freebie that we can mark. So not vertical angles in this case, but we do have a shared side right in the middle. And anytime we have a shared side, we can mark those two pieces congruent to each other. And so now if I look, I've got two angles and a side. If I highlight the side, notice how, in this case, it actually ends up touching both angles in question. So in this case, we put the side in between, and we have ASA. So as soon as you have two angles and one side, you have enough to show that you're congruent. All you have to do is make the right determination. Is the side in between or not for ASA or AAS? So now if we take this and go a step further and look at proofs. So that's what this whole chapter is kind of building towards, was looking at proofs. So if I'm looking at this proof here, the first thing I would do on any proof is write the given. So CB is congruent to HB. And then we have angle H is congruent to angle C. Now, one thing I want you to be aware of here is that at this point, we actually have 5 shortcuts that are possible for these problems. So I could have SSS, I could have SAS, I could have ASA, or I could have AAS, or HL. So I've got 5 different options to choose from as I'm going through these proofs. Now in this case, if I look at the triangles right away, they're not right triangles, so I can automatically eliminate HL. That's not going to be an option in this particular instance. So I've got the other 4 still. So now I start looking at what they gave me. So CB and HB are congruent. So CB here congruent to HB here, so mark the picture. And then it says angle H is congruent to angle C. So angle H in the top right corner here is congruent to angle C in the bottom left. And so from the given information, we have one angle and one side. On its own, not quite enough to show that the triangles are congruent. But then right away, we should be noticing here that right in the middle of the picture, we have vertical angles. So this angle B on top and this angle B on the bottom are vertical, meaning they have to be the same. So now I need to make the statement. So as far as the statement goes, I can't say angle B because I have two different angles or four different angles at that point. So I'm going to call the top angle, angle JBH, is congruent to, I'm going to call the bottom angle LBC. And I knew that those were congruent because of vertical angles. So that was something we got to add for free. Now, as soon as I look at the picture now, I have two angles and I have a side. Now, because I have two angles and a side, I can get rid of SSS, I can get rid of SAS. My only two options right now are ASA or AAS, so I've got to look at where that side is. So if I highlight the side in question for like HB here, when I highlight that side, I notice that it touches both angles that I have marked. Same thing for CB. If I highlight that side, it's touching both angles that are marked. So the side is in between, which means I want ASA. So for step 3, we're going to go ahead and say that the triangles are congruent. So triangle JHB is congruent to triangle LCB, and the reason was ASA. So as soon as I have one of the shortcuts mentioned, I can go ahead and say the triangles are congruent and then simply name that shortcut. If I look at the second example here, so in my next one here, it says angle 4 is congruent to angle 2, so I write that down. Angle 4 congruent to angle 2, and then it says angle R is congruent to angle C. And so in this case, I'm looking at the picture, and again, I have 5 options to choose from: SSS, SAS, ASA, AAS, and HL, which again, I don't see a right angle anywhere, so I'm going to go ahead and get rid of HL right away. Also, if I look at the given information, if I mark that in, so angle 4 right here is congruent to angle 2 up here, and then angle R up in the top left, congruent to angle C down in the bottom right there. Now, as soon as I see 2 angles marked in the picture, I'm going to go ahead and get rid of anything that doesn't have 2 angles. So SSS and SAS are out. So now I know I'm down to ASA or AAS. So now I got to find something to do in the picture and then make my determination on what I have going on. So they already gave me 2 angles. We notice then that there's a shared side in the middle. So we go ahead and mark that shared side, and then I make the statement, DL. So line segment DL is congruent to line segment DL. And I know that that's a shared side. So I start with that. Now, if I've got 2 angles and a side, I'm good to go with the triangle, so I can definitely say triangle RLD is congruent to triangle CDL. But I got to kind of figure out what I'm doing here. So if I highlight the side in question, so here I'm looking at the side. Now here I've got to be really careful. When I look at that side, as far as this top triangle up here, I notice that it only touches this angle down here. It doesn't touch up here at this side, or this angle. So that means this side is not in between the 2 angles that I have marked, and that means then that I have AAS because my side's not in between. So I go ahead and put AAS, and I've got my proof. So with that, you guys should be able to complete the assignment for today, which is the worksheet. So it's going to have somewhere you're going to identify what type of shortcut we're using. It's going to have a couple of proofs, but you should be able to use your notes from the last couple sections to kind of help you through that. Or you can always ask questions in class or email, or check the answer keys on Google Classroom when those are available. So with that, you should be good to go.